Distinguished ladies and gentlemen, I want to welcome you to this inaugural lecture with a new setting, new timing. And that will be on record anyway, that Clinical Sciences is delivering the first lecture to start by 3. Now, the academic procession is about coming in. Please, we want you to find a seat. Leave the walkway, please. Shall we now rise for the academic procession?
the Deputy Vice Chancellor Academic, Deputy Vice Chancellor Research, Innovation and Strategy Partnership, Registrar, Bossa, University Librarian, Provost of the College of Medicine and Postgraduate College, Dean, Faculty of Natural Sciences, Dean of other faculties and of students, Dean of Clinical Sciences, Director and Centers, Director of Child Health, Health of Department, the 12th Vice Chancellor of the University of Ibadan, distinguished guests, ladies and gentlemen. The 566th University of Ibadan inaugural lecture will be delivered by Professor Olukemi Kehinde Amodu of the Institute. Professor Olukemi led the Sacred Heart Primary School, Ibadan, and the Staff School, University of Ibadan, for our primary school education. Our secondary school education was at the International School, Ibadan. She obtained a bachelor's honors degree in zoology, MSc and PhD in molecular biology and genetics, all from the University of Ibadan in 1991 and 1994 and 2002 respectively. She did her postdoctoral training at the R Laboratory, Department of Organismic and Evolutionary Biology, Harvard University, between 2003 and 2005. Professor Olukemi Amodu joined the service of the University of Ibadan Institute of Child Health as a Research Fellow 1 in 2005. She was promoted as a senior lecturer, as a senior research fellow in 2008 and to full professor in 2016. Professor Olukemi Amodu has served the university in many capacities. She was chairperson of the Biorepository Committee of the College of Medicine from 2016 to 2020. Acting Director, Institute of Child Health, 17, and Director, Institute of Child Health, 2019 to 2022. She was a member of the ad hoc committee on the improvement of University of Ibadan global ranking in 2019. She also served as the co-chair of the just concluded and very successful UR75 Innovation International Conference, which took place in October 2024. Outside the university, she has served as PhD external examiner to several universities, including University of Ghana, Legon, and as an assessor for promotion to professorial grade. She has served as an expert reviewer and evaluator for granting bodies, including EDCTP and NIH. Professor Olukemi Amodu's area of specialization is genetics, molecular biology, and public health. Our doctoral studies clearly demonstrated that the malaria pigment in leukocyte count is a marker of disease security in childhood malaria. After her postdoctoral training at Harvard University, USA, she focused on studies in genetic diversity of human and parasite gene studies, which resulted in landmark findings. She has collaborated with several local and international experts as principal investigator and co-investigator in multi-center funded studies, including Malaria Genetic Epidemiology Network, Malaria Gen, and European Union funded networks, Biomapla and Malar, the H3 African Kidney Disease Network, and the Bill and Melinda Gates Foundation Grant Challenges. Professor Olukemi Amodu, since her employment in 2005 at the University of Ibadan, has deployed all effort to establish a genetics molecular biology laboratory from scratch at the Institute of Child Health. She established the pioneering master's and PhD program in public health biotechnology, which has trained 4 sets of MSc students. A total of 96 MSc students since 2006, and currently has 9 PhD and 9 MSc students in training. She established the hybrid e-classroom at the University of Ibadan in 2021 in partnership with FCMB to foster learning without borders. She is a member of some professional bodies, including the African Society for Human Genetics and the LMIC Biobank Cohort Network. She has over 120 publications, including journal articles, proceedings, data sequences, databases, and patents. Professor Olukemi Amodu has supervised over 90 students, 60 MSc, 25 MPH, 2 MPhils, and 5 PhDs. Of course, including 1 international student. And 3 more PhDs will soon join the list. It is my pleasure to invite Professor Olukemi Amodu to present an inaugural lecture titled, "Your Genes Are to Blame or Not."
The Vice Chancellor, Deputy Vice Chancellor Administration, Deputy Vice Chancellor Academics, Deputy Vice Chancellor Research, Innovation and Strategic Partnerships, the Registrar, the Bursar, the University Librarian, Provost College of Medicine, Provost Postgraduate College, Dean Faculty of Clinical Science, Dean Faculty of Public Health, Dean Faculty of Science, Deans of the other faculties and of the students, Director of the Institute of Child Health, Director of Institutes and Centers, distinguished ladies and gentlemen. Mr. Vice Chancellor, sir, my working title for this lecture is "Your Genes Are to Blame or Not," the phenomenal co-dominance of research and training significantly toggled on by the epigenetic innovation landscape. At this point, I must define some terms. Alleles are alternate forms and varieties of a gene. Co-dominance, on the other hand, occurs when phenotypes produced by the 2 alleles are clearly expressed. That means there's a blending between the 2 of them. Epigenetic changes are modifications to DNA that regulate whether genes are turned on or off without changing the DNA sequence. Environmental influences such as a person's diet or nutrition can affect the expression of genes without changing the sequences. It is apparent that the nature versus nurture debate is essential for this discourse. Nature versus nurture is an age-long debate on how much responsibility we can attribute to our genes. Nature refers to genetic inheritance, while nurture incorporates external influences or environmental factors. The major contribution to this debate is the study of twins, both identical and fraternal twins. Studying twins allows researchers to tease about genetic or environmental influences. Identical twins share 100% of their genetic material, while fraternal twins share about 50% just like other siblings. At this point, I can tell you that I can authoritatively join this discourse because my family is a family of twins. My older brothers are identical twins, while my twin brother and I are fraternal twins. So I can talk about this nurture versus nature. For example, in our family, there's one particular trait we all share in equal measure, whether fraternal or identical. I call it a scientific name, undeterred and resolute determination. People that don't know call it stubbornness. But anyway, I can tell you that. So I am here today, a professor at the Institute of Child Health. A representation of the age-long excellence of the Institute is known for. The Institute was established in 1960 with the novel and innovative purpose of a research-focused agenda intertwined with higher education. Distinguished ladies and gentlemen, I stand here today on the shoulders of giants, beginning from Dr. W.R.F. Collis, the founding director, right to Professor Omotade, who I call the connecting link between the old and the new ICH. Mr. Vice Chancellor, sir, I would like to note at this point that this inaugural lecture is being delivered by the first female and the first bioscientist at the Institute of Child Health. My description of codominance in this lecture is the alternate but equal effects of research and training. Research and training have indeed exhibited a codominance in my experience as an academic. I must add that in harnessing these two in my work, I stumbled into the innovation pathway, and it has made a remarkable impact on the overall expression of the two. I must talk about instinctual beginnings and new ventures. We all know that radical advances in medicine were historically and even currently are scientific innovative discoveries that have revolutionized our current world. This background has contributed to my career in genetics and molecular biology with applications to medicine. I've carved out a niche for myself, and I think I enjoy my accommodation. It's a very exciting place to be. My career started with a simple question a physician asked in the clinic. Why do some children develop cerebral malaria while their siblings living in the same area or sleeping on the same bed are bitten by the same mosquitoes and yet do not develop this virulent type of malaria? How do we quantify the extent of intra-person variations in clinical response to similar infections? The variations may vary between disease susceptibility, outcomes, and life-threatening complications. And so this was the beginning of my career. I must say that it has led to a fantastic adventure I've had the privilege to experience and live in, and which I'm sharing a part today. Another beginning was after my postdoctoral training and my return to Nigeria. I was faced with a challenge to make a non-situation into something remarkable. When I started work at the Institute of Child Health, we only had a service laboratory. We were only doing hemoglobin S genotype and ABO blood group. So I was here, given a new challenge. I have new skills, but nothing to work with. Somebody had taken a chance on me, employed a bioscientist into the College of Medicine. I needed to create a niche for myself. A challenge was placed. I needed to take it. I think that's when I began to push into the innovative landscape. I needed to think outside of the box. I had to make something out of the very little I had. And since then, I have worked. And now today, we have a genetics molecular biology laboratory at the Institute of Child Health. I need to talk about my foray into malaria research. Malaria, as we all know, remains one of the major causes of morbidity and mortality. The most at-risk group are children under the age of 5. What determines these clinical presentations from asymptomatic, low-grade infection to mild, uncomplicated malaria and severe life-threatening complications is still not completely understood. But I will share with you some of the journey I've walked. Talk about human factors that we have. As a study, we assessed the effects of individual preventive measures, such as bed nets, on the presentation and outcome of clinical malaria. We found that bed net usage was lower among the severe malaria group, and that the parasite density was higher among bed net users. And bed net users had a higher propensity to develop uncomplicated malaria rather than the severe malaria. So our conclusions from this is that CRO measures or interventions have a certain effect on the environment of the parasite, and that affects the dynamics of the parasite while reducing the malaria burden. My earlier studies were focused on cell biology and phenotypes of the malaria and their role in severity of clinical malaria. I worked on the malaria pigment, or hemozoin, which is produced by the malaria parasite as an end product of the hemoglobin digestion and can be seen in phagocytic cells in the blood. My first paper in 1997 for my PhD studies was the first to present data of the distribution of malaria pigment in leukocyte counts in both asymptomatic malaria and in subjects with no malaria. The results showed that children with both asymptomatic and uncomplicated malaria had higher pigment-containing neutrophils compared to the no malaria group. We tested this hypothesis further in a follow-up study the following year and found that if we included severe malaria, that the pigment-containing neutrophils were much higher among the severe malaria disease. And so we were able to conclude that pigment-containing hemozoin-containing neutrophils are a predictor of disease severity in severe malaria. We looked at parasite factors that affect virulence and how this can explain the severity of malaria. Malaria's parasites have evolved various strategies, such as the capability of developing antigenic variation, and they use this to escape a fully functioning immune system. This mechanism of antigenic variation is important for the survival of the parasite. So the human host, the internal environment, such as the immune response, actually modulates even the parasite genetic factors. So we studied the association between P. falciparum diversity and one of the vaccine candidates, merozoite surface protein 2, and severity of childhood malaria. We found that the complexity of infections and frequency of polyinfections, that's the parasite having many a child having many infections of the parasite were higher among the asymptomatic group and uncomplicated malaria, and these were similar, but was significantly different among the severe malaria group. Among the severe malaria group, they had more single infections, and that is compared with the uncomplicated malaria. After adjusting for age, we were able to find that a child without polio infection, that means a child with single infections, has a 3-fold increased risk of developing severe malaria anemia and a 6-fold increased risk of cerebral malaria. So we looked at the changing environment and how this affects population dynamics. As a follow-up study on the MSP2, we studied the association between diversity at the merozoite surface protein and the severity of disease in childhood malaria in 2 populations and at different times in Ibadan from archived samples. And we found that generally the 2 populations had a high level of genetic diversity and multiplicity of P. falciparum infections, but the 2 populations were different. For the first population, we found that 93% had polio infections, while population B had only 52%. And then we looked at the time in which we collected the samples, and we discovered that one sample was collected in 1998 and 2000, and the other was between 2003 and 2005. And so we concluded that control programs that was about the time when they were changing the first malaria drug in the country. And we concluded that even that, because of the enlightenment campaigns and everything, and the control measures, these activities may have impacted the parasite population. So consequently, any malaria control measure that affects the malaria environment would have a definite impact on the parasite population dynamics. I went on again to look at human phenotypes. The first study we did was to evaluate the role of sickle cell trait and ABO blood group in about 3,000 children. After adjusting for age, gender, and parasite density, we found out that the sickle cell trait was associated with a reduced risk of severe malaria, and among severe malaria subjects, the sickle cell trait was associated with significantly lower parasite densities. But we also discovered that blood group O actually protects against severe malaria, and children with blood group B have an increased risk of severe malaria. So, human genes and malaria. We presented a study on the role of polymorphisms of some certain genes. We call them addition molecules. These addition molecules are host receptors that bind to parasite ligands on the red blood surface, and they are very important in a process called cytoadherence in cerebral malaria. And so we looked at one particular addition molecule, the intercellular addition molecule 1 at the exon 6. And we found that at that SNP, at position 469, that there is a G allele, and this G allele was a risk allele. That means that anyone that has this G allele has an increased risk of developing severe malaria. Our results show that these polymorphisms are important in the susceptibility to severe malaria, and targeting these additional molecules and modulating cytokine responses may hold therapeutic promise. Recently, we looked at drug metabolism genes. We all know that the artemisinin combination therapy, or ACTs as we all know it, is a recommended first-line treatment for P. falciparum in Nigeria right now. Although it's usually safe, but sometimes there are discrepancies that exist in the efficacy of these ACTs in malaria. So we looked at human genes that may contribute to this. And we looked at the cytochrome P450 enzyme, which is known to help to metabolize drugs. And so we looked at some SNPs at this P450 gene, looking particularly at the CYP2B6 SNPs, the position 785. And we found that at the position 785, there are significantly associations of this 785 with malaria, but actually with malaria protection. So this shows that anyone that has this gene may protect against this, against malaria development, in addition to having this gene do its proper work of drug metabolism. I've also worked together with a few consortia on the role of host-parasite relationship and genetic epidemiology of malaria. The Malaria Genomic Epidemiology Network, Malaria Gen, has investigators and partner institutions from about 21 countries, including Nigeria. And from one of the studies, we reported about 12,000 severe malaria cases and 18,000 controls in 12 locations across Africa, Asia, and Oceania. We tested some 55 SNPs, but I want to talk particularly about the finding of the ABO blood group. Combined analysis showed that the blood group O was associated with decreased risk of cerebral malaria and severe malaria anemia. And the SNP that codes for ABO, for the B group, was associated in a dominant gene model with increased risk of severe malaria, which confirmed our study of clinical phenotypes in 2012. So, what does this all mean? It shows that the discussion of malaria epidemiology and genomics so far reiterates the contribution of genetic factors on the debate of why some people resist disease more successfully than others. The external or internal environment of the host, which includes the gene, the immunological response, the defense against pathogens, and the external environment, including the geographical location and even ethnicity, as well as malaria prevention methods and management of the disease, contribute markedly to this discussion. For example, by identifying molecular mechanisms that have a strong association to disease, such as children with group B blood are at greater risk of developing severe malaria. I think this is already a game changer in providing focused strategies in lifestyle changes for mothers of these affected children. This will create an environment which protects the child from being susceptible, even though he or she has the risk allele. I want to talk about population genetics of diseases of public health interest. As we know, that the developing world is currently experiencing a disease revolution as the burden of disease is increasing not only from infectious, but we are having non-communicable diseases that is growing by leaps and bounds. Epidemiology of chronic kidney disease in sub-Saharan Africa suggests a high burden of early onset of this disease. So we looked at the adolescents group, which have been found to have an increased risk of kidney disease arising from prevalent risky behaviors and obesity. So we looked at the relationship between nutritional status and impaired kidney function and CKD, chronic kidney disease. The common risk factors that we found were herbal consumption, abnormal middle or upper arm circumference, and truncal obesity. And when we did the analysis, we found that excess body weight, abnormal mid-upper arm circumference, hypertension, and family history of kidney disease were independently associated with developing of CKD. And we need to understand the interplay between the molecular genotypes and disease development. At this point, we need to understand how to type the phenotypes, because this will help us to provide valuable insights into underlying causes. So we look at genetics of CKD. Many studies have pointed out a particular gene, vitamin D receptor, versus CKD, and we studied this in our population. We looked at 3 SNPs. I'm just going to give an example of one of the SNPs, which is the CVI-OR. We found a significant risk association of the CVI-OR with CKD under the dominant inheritance model, indicating a high penetrance of the traits. What that means that while also the CVI-OR was associated with protection to CKD under the recessive inheritance model. So we concluded that the homozygotes are at risk, while the heterozygotes protect against CKD. We need to do more studies to delineate this. We looked at the study for genetics of prostate cancer. The majority of prostate cancer with a worse prognosis among Africans is actually caused by genetic factors. So we need to know these genetic signatures of prostate cancer, and this is essential for development of tests for susceptibility of genotypes early in life. So we carried out a pilot study to determine the genetic association of a particular gene, P53, and prostaglandin pathway gene variants in prostate cancer among men and also adolescents here in Ibadan. And we found that the P53 gene and the prostaglandin gene had high increased risk of prostate cancer. The genetic variants of P53 and prostaglandin synthase were found to be associated with prostate cancer. And we also found the presence of these risk genes among adolescents, though in a low frequency. And this infers that these adolescents have the risk genes, and they must begin to talk about a right environment for themselves, because later in life they could develop prostate cancer. So in putting this together, our studies support evidence for the role of contribution of genetic factors to the risk of chronic kidney disease and prostate cancer. And we have also provided the opportunity to assess and justify the development of a prostate cancer rapid diagnostic test strip that detects risk polymorphisms among our population. And therefore, if we're able to test these genotypes early, for example, in these adolescents, lifestyle changes will help create a right environment, which is important for these genes not to manifest. Mr. Vice Chancellor, sir, I would like to tell the story of another venture. I remember many years ago, when Professor Omotade and I were the remaining academic staffs in ICH, we used to have meetings every day. And so we had a lot of discussions about developing master's courses. And there was one challenge he gave to me, that he wanted a master's course that will have application of genetics in medicine, so that this would be an add-on to his own Master's of Public Health program in child and adolescent health, which was the first of such globally. So we discussed this. Of course, we moved on to other things. Colleagues joined us, and I was busy with other things until one day in 2010, February, I can remember very well, when Professor Omotade barged into my office and told me that I should not speak to him for the next 2 months until I delivered the curriculum. So I entered into a new world for me of social innovation in educational reforms, setting new teaching strategies and methods, which introduce new technologies and curricula to improve educational outcomes. I needed, amongst other things, a course that is so wide that students could choose the different specialties from, and from then they could go on to other specialties for their PhD. Thus it began. Another of my career goals to build capacity for development and research in genetics and molecular sciences. So the Public Health Biotechnology program was born. This is a pioneering academic MSc and PhD program. It's a unique blend. It's a program studying disease of public health importance from the perspectives of genetics and genomics in Nigeria. It's an interdisciplinary concentration in the study of biology, basic biology, genetics, genomics, immunology, bioinformatics, and public health. And this, together with public health diseases, with translational research as its ultimate goal. We also teach, as a master class in public health biotechnology, a master class with specific objectives and targeted outcomes. What are the privileges of our brand? When I was director of Institute of Child Health, I pioneered the drive to engage international lecturers as adjunct staff to the university. Among these renowned experts are immunologists, human geneticists, parasite genomic experts, a statistical geneticist, global health experts who teach and mentor students registered for the program. In 6 sessions, we have trained 96 MSc graduates and 2 MPhils. We have 6 PhD and 8 MSc students currently in the program. A total of 17 graduates. A total of 17 of our graduates of this program to date have obtained scholarship for fully funded PhD programs in the US, Germany, Australia, and Nigeria. And in fact, one of them just got a letter from Qatar today. Others are doing well in their data science and relevant fields. Our graduates, this was written by one of our alumnus, who is also doing a PhD in the US. Our graduates are rated highly in knowledge, top 5%, presentation skills in the top 1%, as well as the ability to learn and adapt in the top 2%. These are the skills we develop in this program. I'm going to read a testimony of one of our students. The Institute of Child Health was the highlight of my academic career. It was a learning ground. The learning style was more focused on the understanding of the concepts and the applications in health. I completed my master's in public health biotechnology and received an all-round knowledge in molecular biology, public health, genetics, and statistics. The standard of teaching was top-notch, and my colleagues can attest. Our lecturers treated us with respect. Our contributions, opinions, and questions were never ignored. The program is the best biotechnology in Nigeria in the best university in Nigeria. In October 2021, the First City Monument Bank, FCMB, helped to fulfill one of my major goals as the then director of Institute of Child Health by equipping the first hybrid e-classroom at the Institute of Child Health using the innovative Wawi Idea Hub. The e-classroom provides the medium for collaborative teaching with international experts and collaborators to meet the increasing number of students and provide diversity and internationalization to the public health biotechnology program. Since 2022, we have had about 45 international programs in that e-classroom. Now, I want to talk about my experience in innovation landscape. From building a laboratory from the scratch, I had to learn to think outside the stifling block. I had to make a definite shift. Sometimes to get myself out of a corner, I had to stretch beyond myself. And then I had to go on to develop a curriculum of a program that was starting from fresh and getting international staff to come and teach this program. I think all this brought together a revolution of research to impact for me, so that more and more are moving towards people or population-centered research. And population-centered research is an impressive approach that places the individuals at the heart of the scientific inquiry. So we focus on the genetic diversity and diseases of public health importance within our population so that we can tailor more effective interventions accordingly. One size does not fit all. We must bridge the knowledge gaps in our research. So one of these examples is hypothesizing the link between malaria and non-communicable diseases. So we looked at type 2 diabetes, T2D, I'll just call it T2D from now, and malaria. Both of them are inflammatory diseases. And so we hypothesized that there must be a cytokine that is similar between the two of them. And we found out that the TNF-alpha, tumor necrosis alpha, is very important in malaria pathogenesis and is also important in type 2 diabetes because it leads to impaired insulin signaling. So we did this hypothesis, and we are looking forward to doing more work to be able to see, is it possible for us to be able to identify an important link, and maybe this will help us in managing both diseases, either the single disease status or comorbidities. I move on to our biotechnology strategy and innovation lab. As we know that research to social impact is a critical move with the goal of creating solutions, and that is what we intend to do at this lab, develop new techniques, processes or services that will impact the society. And one major thing, I got into this research when Professor Oluwatosin threw a challenge to me. He's in plastic surgery, and we have started thinking about using leeches. So we needed to identify leeches in our population. So we've been able to do that. We've been able to type the leeches, identify that we have medicinal leeches in our population. So our goal is from identification to application. We are still on that journey, and we'll still have many days to tell you about it and where we get to. For research to be truly impactful, it must transcend the confines of academia and generate tangible social change. Innovation at its core is realized when research addresses and resolves pressing societal issues. This understanding was central to the creation of what we now know as the Biotech Hub, where I recognize that groundbreaking research cannot flourish in isolation. It requires ongoing mentorship and guidance. And so we developed a nurturing environment to support young researchers and scientists long after they have finished their academic degrees. Our goal is to bridge the gap between when you complete your master's, navigate the often overwhelming postgraduate landscape by providing continuous mentorship. Today, that hub boasts about 90 members, including current students, alumni, and prospective students. It serves as an open platform for interaction, idea stimulation, and mutual support. I want to talk about social innovations for public health impact. Social genomics tells us that social factors affect our gene expression. Epigenetics are also environmental factors that don't touch our sequences. So why am I talking about this? I think it's a combination of the two of them. working in my field, working in public health, and working with people around me, and developing ideas that have social impact. So our team developed innovative childhood immunization strategies to address challenges such as timeliness, complete childhood vaccinations, and to increase the uptake of childhood immunization among working mothers. During this period of our project, we cut the time spent by mothers at the clinic to 7 to 10 minutes, rather than 3 to 5 hours spent at traditional clinics. We achieved an overall 67% vaccination completion rate, which was a 44% increase in completion rates when compared with Oyo State baseline data. And we recorded 0 drop-off rates. Now, putting all this together, COVID-19 was a game changer in Nigeria, bringing genome research right before us. As a result, there are many genome facilities and infrastructure that have been set up in some places in Nigeria. Genomics is particularly relevant to Nigeria with the increasing burden of infections and chronic non-communicable diseases. Despite these advancements, however, challenges still persist, including limited medical genetic testing centers and clinics and genetic counselors in Nigeria. Many patients with genetic disorders remain undiagnosed, and emphasizing the urgent need to enhance genetic research frameworks within our country. Thus, setting up a genetic testing center and a medical genetics unit are crucial, with the University of Ibadan setting the pace. A concerted focus on improving genetic research in Nigeria is needed by fostering collaboration across various disciplines, securing local and international funding, and advocating for government support to advance genetics research. Only through such collective efforts can Nigeria address the growing burden of disease and pave the way for a healthier future. This need is crucial because it is the foundation for translational research. Mr. Vice Chancellor, sir, it is essential for the Nigerian government to invest more in research, especially genetic research, by providing funds so that genetic research will not just depend only on international funds. There is a wide gap between the academia, the industry, and society, with only pockets with some great genes in my life. Some great genes in my life. I want to thank my community of teachers right from primary school. I want to thank my community of teachers right from primary school up to the university. I will mention Dr. Adekunle Mosuru for creating an enabling environment for me to pursue my studies in genetics, and to Professor Mark Owagu, who opened my eyes to the world of molecular biology. I also mentioned other teachers, Professor Odaibo, Professor Hassan, and Professor Rosangela Umumba. To my community of pillars, Professor Oladapo Walker was the one that asked the question that set me on this academic journey. Thank you, sir, for setting an example of academic discourse and insightful interaction with students. I have 3 great men in my life. Dr. Peter Olumese, my supervisor for PhD, Dr. Adebo Ali Adeyemo, and Professor Rashid Badegeshi. These 3 men together, they mentored me on leadership, sat with me in the lab, taught me how to be a team leader, taught me everything I know in the science world, taught me how to hold my own in the science world. Together, they teased me out of my shyness, taught me how to hold my own, treated me like a little sister, yet with the deep respect of a colleague. A really very big thank you, sirs. Today, your little sister is now a big girl. My advisor in ADVAD, Professor Daniel Hatto, has a significant influence on me as a person, and he helped me with my journey as an academic. Thank you, sir. And to Professor Motadi. The one who took a chance on me. I stand here today, sir, to say that your experiment has brought its dividends, sir. Thank you, sir. To my working community, to Director of Institute of Child Health, Professor Rimadegu, and to all my academic colleagues and the non-teaching staff, past and present, thank you all very much. Special mention to Dr. Shubulade Ademola, whose passion for teaching and dedication helped the initiation and subsequent success of the Public Health Biotechnology program. Thank you all. From UI and UI community, I thank the Provost of the College of Medicine, the Deputy Provost, the current Dean of the Faculty of Clinical Sciences, Professor Lawal, thank you, and the former deans, the present and former faculty officers, the current Dean of Public Health, Professor Dairo. We are in 2 faculties, and former deans and of Faculty of Public Health, thank you very much. I also want to mention great bosses, Professor Idowo Ilayinka. He always supports me at every point. Thank you very much, sir. And Professor Adigun Agbaje, thank you very, very much, sir. And to my sabbatical work community, old and new friends and colleagues at the University of Medical Sciences on sabbatical leave. The Vice Chancellor, ably represented by the Deputy Vice Chancellor, and the Deputy Vice Chancellor, my teacher and my big sister, Professor Rosangela Umuba, thank you. And my big brother, Professor Olumide Ogodansi. And Professor Yetunde, thank you very much. And all the staff of the Center for Molecular Sciences and Medical Genomics, where I am serving as director. To my community of students, all my mentees, students, former PhD and MPH students, all the students past and present PhD at the Public Health Biotechnology program. And special mention to the pioneering set. They actually set the tone for our master's program. Thank you very much. I thank my community of collaborators from Biomalpa to H3 Africa. Professor Salako is here. Thank you for providing an environment for my research traits to thrive. Thank you very much. And to those I call collaborators who have become friends, Professor Bamidele Tayo from Chicago, US, Emeritus Professor Troy Blumberg and Carmen Fernandez, Professor David Burke, Professor David Conway, and Professor Lucio Luzatu. Thank you for your continuous support and for sharing your expertise with us at the Public Health Biotechnology program. I have a dear friend sitting in the center today, Deji Adeni. Thank you so much for your continuous support. And to my ISI 87 set, thank you so much for friendship. And my friends, I mention you particularly, Mrs. Adedayo Oke and Dr. Nena Oluigbo. Thank you so much. And friends who are actually family friends. Brother Sam, that's how I call him, Dr. Ajayi. The Ekonlas, thank you very much. The Omobo Alays and the Oluwatosins. Thank you very much for your constant love and support for me. To my Block 11 neighbors, thank you for the community of peace. We have peace in our block, honestly. Thank you very much for many years of peace. I appreciate you all. My team. A woman needs a team of people who stand solidly with, around, and behind her. I have found such an amazing team. Thank you all very much. I can't list everybody's name, but I just want to say thank you to all of you. To community of pastors. These are men who have made an impact in my life. They share their ministry and their dedication to God with me. Pastor Afolabi Adedeji, thank you, Father in the Lord. Thank you so much for being here, and Sister Mo. Thank you, dear pastors, Shola Mene, Jide Adedeji, Jide Adeniran, Patunaji, and Folajimi Sadiq, and also Professor Omokodion. Thank you very much. To my church family, I absolutely treasure the Restoration family, members of the Restoration Global Bible Church. Thank you, pastors, deacons, ministers, leaders of the service groups, every member from young to old. Thank you for all of your fellowship, brotherly kindness, and for the love of God that manifests in your life. And to my family. My dad. Well, I should say late, because it's late. Dr. Agbola Adebayo Amodu, a renowned veterinarian. I've had many testimonies of his great intelligence. I can only hope I'm following in the tradition. My mom, Olayinka Wura Ola Amodu, a mother indeed. I watched and learned from her. Very strong woman, with a passion and dedication to giving the best and bringing the best out of our children. I salute her courage for bringing up 4 children all on her own. Thank you, ma. I have her, she can't come today, but she's so precious. Thank you, ma. My big brothers, you know I mentioned earlier that we all share one trait. You see that trait, you have to learn conflict resolution early with that trait. Because everybody has an opinion, and nobody is going to release his opinion. So you learn how to agree, to disagree, and go on to the next argument. Thank you, my brothers, for teaching me how to have an opinion, make it my own, and stick firmly to it. I appreciate your wives and your children. Thank you. My aburos, Dayo, okay? Thank you, dear sister and beloved husband, Bobola, of my aburo, their children. And to Olaiwola Okusaga, his wife and daughter, thank you for the gift of family. I also mentioned Pastor Shayo Akisola and his wife my dear childhood friend, Aditola. To my larger family, the Amodu Ayeni and the Okusaga families, thank you for the gifts of family. The cherished sons, they are just too precious for words. My sister, prayer warrior, loyal friend, thank you for marrying my brother. Thank you. In marrying my brother, I gained a sister. I gained a friend. Thank you. And to my twin brother. My friend, I'm going to tell you a story. I didn't know whether I was going to have time to do that. Many years ago, when we were changing schools, we were about maybe 5, 6, I can't remember. My mother told us this story. So we were doing exams. We were supposed to do qualifying exams. And my brother refused to write anything. So the headmistress got worried and went to him that, why are you not writing anything? And he looked at her and wondered, why are you disturbing me? And she kept pestering him. He now told her that, look, Ma, ask my sister. She knows everything. That is my brother. Right from childhood, never has a sister had such a faithful and thoroughly proud brother. Thank you very much, sir. And to God, my Father, my Lord Jesus, my help, the awesome, unsearchable fountain of knowledge, the God whose depth is bottomless, the eternal, the self-existent God, the one for whom I exist, I thank you. If you have followed my lecture, I have emphasized the role of genes, and I've also described that the environment impacts the expression of a good or a bad gene. Therefore, can our genes truly be blamed or not? I think we need the right environment. And so I leave you with this prayer. May the peace of God find you.